In the control chart tutorial, we hinted at finding patterns in the data points and how patterns could indicate a process being out of control. In this tutorial, we will formalize that by looking at two runs tests for patterns in the data. Specifically, we will be looking at two types of run tests, the up-down test and the above-below test. For illustration, we will be using example number 1 in the xbar tutorial and example number 1 from the p-chart tutorial. As you will recall, the xbar chart looked fine while the p-chart appeared to have a pattern. The slide shows the xbar chart from example number 1. This is computed using the range, although that does not affect us since using the test only uses the center line and the points. Here, each point, except the first one, has been labeled with either a U or a D. U represents that the line coming from the last point sloped up, while the D represents the line coming from the last point sloped down. The first point does not have a U or D because there's no prior point. Putting those letters together, we have D, U, D, U, D, 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 U, U. We now count the number of line segments. 1 to 2 is down, 2 to 3 is up, 3 to 4 is down, 4 to 5 is up, 5 to 8 is down, 8 to 10 is up. So, there are 6 up-down line segments for 10 samples. That will be the basis of our up-down test. Before beginning, I should point out that the above-below test is technically based on the median and not the mean. Since control charts show the mean is typically very close to the median, and textbooks use the mean and not the median, that is what we will use in this tutorial. Here, each series that is completely above or below the mean has been circled. Point 1 is above and 2 is below, so 1 stands alone. 2 is below and 3 is above, so 2 stands alone. 3, 4, and 5 all stand alone for the same reason. 6, 7, 8, and 9 are all below the mean, so they are all in one circle. Point number 10 just happens to be exactly on the mean, so it is not circled at all because it is neither above or below the mean. We have 6 circles on the chart. Once we know how many up, down, and above-below values we have, we need to test to see if the number we have is something reasonable for random chance, or if it is not something we would expect from random chance. To perform this test, we need to know 3 things. 1. The number we would expect from random chance. This is the expected value. 2. How much variability we would expect in the expected value. This is the standard deviation. And 3. How to handle this probabilistically. Both distributions are normally distributed, so we will convert the actual observations to a z-value. If it is between negative and +2, we will conclude that there is no pattern. Outside this range, we will conclude a pattern exists. The expected value of the above-below test is n divided by 2 quantity plus 1. In these formulas, the n is the number of points on the chart and not the size of the sample used to compute the points. That is why it is a capital N and not a lowercase n. The expected value of the up-down test is 2n minus 1 all divided by 3. The standard deviation of the above-below test is the square root of n minus 1 all divided by 4. The standard deviation of the up-down test is 16 times n minus 29 quantity divided by 90. The numbers used in these formulas are constants and do not change. For the example, n equals 10. That gives us an expected value for the above-below test of 6 and an expected value for the up-down test of 6.33. The standard deviation for the above-below test works out to 1.5, and the standard deviation for the up-down test works out to 1.206. We compute the z-value for either test as the actual number of runs counted earlier minus the number of expected runs computed earlier, quantity divided by the standard deviation of the number of runs computed earlier. For the above-below test, 6 minus 6 divided by 1.5 equals 0, so we conclude the process is in control based on this test. For the up-down test, 6 minus 6.33 divided by 1.206 equals negative 0.276. This is within plus or minus 2, so we conclude the process is in control based on this test as well. Using the p-chart example shown on the slide, use the above, below, and up-down runs test to see if the process is out of control. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. This example has 20 points. In the above-below test, there are 10 runs as shown on the slide. The up-down test is shown on the slide. This one is somewhat tricky. Some of the points are beside each other and have the same value, so they do not go up or down. You can see this in points 1 and 2. The trick is to remember that we are not interested in the actual up or down points, but rather the change in direction. For points 1 to 3, the points are either flat or increasing, so our run is 1 to 3. The points decline or are flat until point 5, so our second run is 3 to 5. They increase or are flat until point 8, so our third run is 5 to 8. 8 to 9 makes the fourth run. 9 to 10 makes the fifth run. 10 to 11 makes the sixth run. 11 to 12 makes the seventh run. 12 to 14 makes the eighth run. 14 to 15 makes the ninth run. 15 to 16 makes the 10th run. Finally, 16 to 20 makes the 11th run. For the above-below test, the expected number of runs works out to 11. The standard deviation computes to 2.179. That yields a z-value of negative 0.459. For the up-down test, the expected number of runs works out to 13. The standard deviation computes to 1.798. That yields a z-value of negative 1.112. Both are within plus or minus 2, so we conclude the process is in control. This shows that a process can appear to have a pattern, but the statistical test not find one. Please note that in addition to these two run tests, there are rules of thumb for a process being out of control. We will briefly cover some of the more common ones. They are based on the color-coded control chart shown on the slide. Zone 1 is the area from the center line out to 1 standard deviation unit. In a normal distribution, we would expect about 68% of the points to fall in Zone 1. Zone 2 is the area from 1 standard deviation unit out to 2 standard deviation units. In a normal distribution, this would contain 27% of the points. Zone 3 is the area from 2 standard deviation units out to 3 standard deviation units. In a normal distribution, this would contain only about 4% of the points. Some rules of thumb are as follows for control charts being out of control. 1. 8 consecutive points on one side of the mean. These would all be a single run on the above-below test. 2. 8 consecutive points up or down. These would all be a single run in the up-down test. 3. 14 points alternating up and down. These would be 14 runs in the up-down test. 4. 2 out of 3 consecutive points in Zone 1 on one side of the center line or the other, but not both. 5. 4 out of 5 consecutive points in Zone 1 or 2 on one side of the center line or the other, but not both.
If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.